coefficients. Okay, so let's do this one. This is gonna be, I'm just gonna do it very small if I can. So it's gonna be like this, negative. This is negative, this is positive, goes here, then this goes here, this one. So this is the output for this is the proportional one, right? This is an inverting amplifier. So this signal, it's gonna be if this is V in divide, if let me call this one R1, this one R2, then V in divided by R1, it's gonna be equal to negative VO divided by R2. So VO, this voltage, it's gonna be negative R2 divided by R1 times V1, right? So what is the transfer function of this system? It's this one, right? You multiply this one by the input, you get the output. Okay. The second one is the integrator. How do we do integrator? We already did that. This is R. This is, let me call it R3. Negative, positive. This is grounded. It goes to, let me call this one C1. Okay, and this is VO proportional. This is VO integral. And we already did that. It was negative 1 over RC times S times V, not V1, this voltage, whatever this is. Like, let me call it V diff. Or let me call it error. It's better. Okay, so the transfer function of this system is this one, right? And it takes the integral of this signal, multiplies it by this coefficient. So this coefficient is Kp. This coefficient is Ki. Okay. And the last one, it's the differentiator. So let me call this one R3 and C1, and this one is C2. Excuse me. Negative, positive, this is grounded. This is, let me call it R4. So this voltage, let's call it VO of, D, differentiator or derivative. It's gonna be negative of RCS times E. Okay, again, this is, and this is R4 times C2. And this is the transfer function. The whole thing is the transfer function of the system. This part is KD. Good? So we created each of these terms separately. Now we just have to add them, right? Now we have to add them. Do we have a circuit that adds 3 voltages? Yes, we do, right? So what I'm gonna do here, let me actually write these terms here. VOP is equal to negative R2 divided by R1 times E. VOI is equal to negative 1 over R3C1 times E. VOD is equal to negative R4 C2, there's an S here, S times E. Now I'm just gonna erase these ones. I want to add these together, right? So do we have a a circuit that adds 3 signals together? This is D. Yes, we do, right? So what we do here is basically, let me do it with another color, like maybe green. This one, this one, this one, connect them together. Let's go to the inverting pin of an op amp, sorry. This one is grounded. This one is the same voltage. So again, if all of these are equal, VO, it's gonna be negative of V, let's call it VP, VI, and VD. It's gonna be negative of VP plus VI plus VD, right? And that's the reason I used an inverting amplifier here, because I wanted all of them to have a negative one that gets cancelled out by this negative sign here. So now if I replace these terms here, I end up with VO is equal to R2 divided by R1 plus 1 over R3 C1 times 1 over S plus R4 C2 times S, the whole thing times E, right? So this is actually, this is the transfer function of this bigger circuit. It takes E and it multiplies it by this transfer function. We get this output voltage, which is actually this one. We called it VO. I shouldn't have called it VO, but like this is like the output I get from the PID. Let's not call this one V out. So this is V out, the output from the PID. And so this is how you can implement a PID system using op amps. This is used in analog circuits, so we can use it in analog circuits. We implement this one using a subtractor. Then we have an amplifier, an integrator, and a differentiator here. And then we add them up using an adder. So we can use this one, and then you can supply this voltage to your plant, and like however your plant is, like whatever it is, it's a motor, it's a buck converter, whatever it is. So this is how you can implement a PID controller using a feedback loop. So that's what I'm gonna, that's what I wanted to mention. The transfer function that we have talked about in this course is only for system single input, single output. So let's just like not talk about the bigger transfer function here, because now we have 2 inputs here. We can just like go a little bit later. If you add this one, then you